So here the question tells us about a cubic function, which means it goes up, down, and up again. It has two tails, this one and this one, that point in opposite directions. We also see so that's f of x. We also see a line called g of x that intersects with this graph. Okay, and we see it cuts the x-axis at -3, -1, and -2. These are the roots. The values of x where a graph hits the x-axis are the roots of that function. It hits the y-axis at this point here, 0, -6. First question is to verify that it can be written like this. So that's telling us this is true. We want you to prove it. Now the word verify means that we can use this to prove it. If it said show, we would not be allowed to use this. So the easiest thing to do here is to show that these three roots here, when you convert them to factors. So first we want to convert to factors. Okay, there we go, factors. Now that's by the factor theorem. So this is from algebra. If you don't remember this, look back at the algebra notes. But basically, if x is equal to -3 is the root, that's the root, then a factor would be x would be x plus 3 equal to 0. Okay, so you just carry it across so that 0 is on the other side, and then this here, this x plus 3 is your factor. Okay, so the three factors are x plus 3, x plus 1, and x minus 2. Multiply these out, and you get this. Proven. Okay, the other way to do it is to plug in each value for x and show that it equals 0. So the other thing about roots is because they're on the x-axis, you can see the value of y here is at the space level, it's 0. So at the roots, y is equal to 0. If you can show that for each of the roots, you've shown that this is true, that this is the function. Okay, so the next part now is part B. Part 1. The graph of the function g of x minus 2x minus 6 intersects the graph f of x above. We can see that here. Now -2 means it has a negative slope, so it's pointing down. This negative 6 means that's the y-intercept, so it touches the y-axis here at -6. Because they're intersecting, to solve for the point where they intersect, you set one equal to the other. So you could do it graphically. We could see that's what we could do it graphically, but sometimes that is going to be inexact. That's going to be inaccurate if we can't read the graph accurately. So it's more accurate to do it mathematically. So it tells you to do it mathematically. Let f of x equal g of x and solve the resulting equation to find the coordinates of the points where the graphs intersect. So do exactly what they say. Set one equals the other. So f of x is this cubic function. G of x is this linear function. Linear means that the highest power is 1, x to the power of 1. Cubic means the highest power is x to the power of 3 here. Okay? So carry everything across to one side. Carry this across to one side. Okay? So we have 0 here. Now, usually with cubic functions, you have to find the first root by trial and error. But in this case, do you see how there's an x term in everything? There's no constant here. So we can divide by x. We can divide everything by x. Now this is the same thing as saying, it's the exact same thing as saying x minus 0 times the rest of it, ... equal to 0. So that means that this term here, that x minus 0 is a factor. So, as in, same thing as saying x is a factor. X is a factor. So remember, factors are what we multiply together to get the function. But if you can multiply by x, then x is a factor. Or, x minus 0 is a factor. So x minus 0 is a factor, so x equal to 0 is a root. Okay, so one of the solutions is x equal to 0. So now you just factorize the rest of this the normal way. So what do we multiply together to get negative 3? 1 times 3. So we have 1 times 3. And how can we add or subtract 1 and 3 to get 2? You could do 3 minus 1. So minus 1 plus 3. And there's the x squared coefficient is 1, so it's just x times x. Solve for this. Draw a line down here. X minus 1 equal to 0. X equals 1. X plus 3 equals 0. X is equal to minus 3. So these are your 3 roots. Okay, these are the roots. Now, you're not done yet. I told you to get the coordinates, not just the roots. So for each of these values of x, we have to find, well, what is the value of y? The messy way to do it would be to plug it into the cubic function here. The easier way to do it would be to plug it into the linear function, but you would get the same answer either way. So you could do y is equal to negative 2 times 0 minus 6 would be minus 6, you can see here, or y is equal to negative 2 times 1 minus 6, which would be minus 8, or here, or you could do y is equal to negative 2 times negative 3, minus 2 times minus 3 is 6, because the minuses cancel, minus 6, 0. These are your 3 points. Job done. Part 2 here, draw the graph. Okay, so the easiest way to draw a linear graph, as we say here, is to find the points where it hits the x-axis and the y-axis. You find where it hits the x-axis by setting y equal to 0. So by setting y equal to 0, so the easiest way to do this is to say, okay, well, we'll set y equal to 0, so g of x equal to 0, which is going to be equal to, this is different from the way they do it, but this is the easier way, minus 2x minus 6, and then get the value of x. If we carry the 6 across and divide by 2, you'll get x is equal to negative 3. And obviously, because we said y is equal to 0, y is equal to 0. So this gives us the point. We're looking to get 2 points here, negative 3 and 0. Then you find, so that this is where it hits the x-axis. Now we want to find where it hits the y-axis. So set x equal to 0. See here, we've set x equal to 0. So that's going to be the exact same as it is here. X equal to 0. Replace x with 0 everywhere. We get minus 6. So x is 0, y is minus 6. This is your second point. 1 point, 2 point. And you can then draw it in here. So this is minus 3, 0. This is minus 6. This is 0, minus 6. Connect them together. The line does not have to finish here. You can draw it right through. And make sure to label your lines always, but not to cover them in a red circle like that.